Okay, I think this actually just gives us a motivation for defining this this number. So if again for any given x, we may find a number f prime of x in this process in this way. Okay, different x, different values of x may be obtained, maybe obtain different rate of change, okay, rate of changes or derivatives. So we may treat x as a variable, and in this time we call f prime again the derivative of x. F prime of x is derivative f at the number x. Sometimes we also call this one the derivative of f because we emphasize the variable is x. The variable is x. So this is the section 2.2, the derivative as a function. Delta y over delta x. What? Oh! Yes. Aha, thanks. Gracias. Or merci. Merci. Merci beaucoup. Okay. So, for a given number x, a fixed number x, we can find this one if this limit exists. Different x's, values of x obtain different derivatives of this function. So we may treat x as an independent variable, and so its derivative may be treated as a function. Treat it as a function. This is the definition. Here we give two terminologies. One is differentiable. Another one, at some point, we say a function is differentiable at a number a if its derivative at a exists. In fact, for a given function, this is a limit of this difference quotient. We don't know the existence of this limit. If this limit exists at a, then we use this terminology. F is differentiable at a. OK. 如果 f 在 a 的导数存在，我们就说 a 在 a 可为。导数跟可为是两个不同的单字。你不要讲那个是 f 的微分啊，那个是 f 的导数。This is the derivative of f at a. F is differentiable at a. Two different verbs. Words. Okay. Similarly, the limit at prime a is considered this one as some number x or some number a is a local property. But if we have an open interval, for example, maybe a finite open interval, maybe infinite open interval, or the entire real line. Because open interval for an open interval time, every number is an interior point of this interval. So we can consider two-sided limits. Two-sided limits, h goes to 0 from the right and from the left. Okay. Of course, you can define one-sided derivative, more precise, more detailed, but we don't want take time to describe such a maybe not so important thing. You can realize them by doing exercises, and you will learn such a one-sided element. So here, if the derivative of a function f at some number a exists, then we use this terminology. F is differentiable at a. If an open interval I is given, we say f is differentiable on that interval. That means f is differentiable at every point of that interval I. Okay. Very good. So what time it is now? Oh, we still got 5 minutes. In chapter 1, we learned limits, continuity. Chapter 2, now we learn differentiability. A function. Before we consider function at the point A have a value A, but in calculus we deal with a function maybe unknown or undefined at A, but we still can study this function by at A the behavior by what? By the behavior of the function f. Acting on the neighborhood of A, on on the neighborhood of A, on neighborhood of A, then automatically some number happens. Okay, if at A, f of A is also considered and this limit exactly the value of x at A, then we say this function f is continuous at A. Okay, now differentiability, wow, more stronger than before. I mean the condition is more strict. Locally, linear, like a straight line. So we must be continuous at A. So the following theorem is exactly says this, the following theorem exactly says this property, differential ability implies continuity. F is differentiable at some number A, then F must be continuous there. Okay. So this one is the strongest. Implies this one implies exists. So if differentiable at A implies continuous A, implies F has a limit at A. If F is differentiable at A means this number exists. By definition, this number is the limit of x approaches A. F of x minus f of A divided by x minus A. In order to prove f is continuous at A, we have to evaluate this limit and try to use this condition, like some exercise 4 minus f of A divided by x minus A. If we times x minus A and then plus f of A, then these two numbers are the same. Okay? Cancelled. Since this limit exists, polynomial, constant function is f of A. So by the definition of continuity at some number, f is continuous at A. Okay, so some observations can be described in some expressions in math. Take a break.